Okay, here we make an open box by cutting away four identical squares from the four corners of this cardboard piece with the dimensions 16 inches and 24 inches, and then folding the flaps. Let x inch be the side length of the each of the identical squares that we get, and so we can see from the figure that 16 minus 2x will become the length of the box, and 24 minus 2x will become the width of the box, and x inches will become the height of the box, which means we can now write the volume equation for this box. So we write volume this equals length times width times the height of the box. We put the expression for length, which is 16 minus 2x, times the width of the box is 24 minus 2x, times the height of the box is x. So let's simplify this. And so this gives, I can factor out 2 from this one and make it a little bit simple. So this becomes 8 minus x. I can also factor 2 from this expression. So this becomes 2 times of 12 minus x, and then we have x. So here we have 2, 2, 2. So product of these will give 2 times 2 is 4. 4 times x is x. So here we get 4x times 8 minus x times 12 minus x. Now let's distribute 4x, or before that we can FOIL these two expressions. So first let's FOIL this. We have 4x times 8 times 12 is 96. 8 times negative x is negative 8x. Negative x times 12 is negative 12x. And finally, we have negative x times negative x is positive x squared. So let's simplify this. And so this gives 4x times 96 minus 8x minus 12x is negative 20x. We then have positive x squared. We can now distribute the 4x into the terms inside the brackets. So first I write 4x times x squared is 4x cubed. We then have 4x times negative 20x is negative 80x. And finally we have 4x times 96 is 384x. So we have obtained the expression for the volume. We can write down this in a function notation. So this is the volume function v of x. Basically, in this question, we have to determine the dimensions of the box so that the volume is maximum. And that is why we have written the expression for the volume. So let's use the calculus first and second derivative test to obtain the critical numbers of this volume function, and determine at which point the volume is maximum, and also determine the dimensions. So I'm going to first to find the derivative of this volume function, since we are going to find the critical number by setting up this equation, that is v prime of x equals 0. So let's find the derivative of volume function, which is v prime of x, and this equals the derivative of 4x cube is 4 times the derivative of x cube is 3x squared, minus 80 times the derivative of x is 1. I'm sorry, actually this one is 4x times negative 20x is negative 80x squared. So this has to be x squared. And so if we find the derivative of x squared, we will get 2x. So this one will be negative 80 times 2x. And then the derivative of this one is 384 times the derivative of x, which is 1. So we get the derivative function v prime of x equals 12x squared minus 80 times 2 is 160x plus 384. Now let's replace v prime of x by 0 and solve for x. So 0 equals 12x squared minus 160x plus 384. Basically, this is a quadratic equation which we can solve for x. So first I'm going to divide both sides by the common factor 4, and rearranging in terms of quadratic expression. So 12 by 4 is 3, So I write 3x squared minus 160 divided by 4 is 40. So I write 40x plus 384 divided by 4 is 96, and this equals 0. So here we have obtained a quadratic equation. We can use the formula to solve for x. So we say x equals, the formula is negative b plus minus square root of b squared minus 4ac. This is divided by 2a, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. So let's plug in all this value. Negative b equals negative 40, so negative b will be 40 plus minus square root of b squared, which is negative 40 square, minus 4 times a, which is 3, times c, that is 96, and this is over 2 times of a, which is 3. So let's simplify this and find the values of x. We have 40 plus minus, this is square root. Negative 40 square is 1600, and multiplying these three numbers, we get 12 times 96 equals 1152. This is over 2 times 3 is 6. And so this gives 40 plus or minus 1600 minus 1152, and this equals 448. This is divided by 6. So here we find the square root of 448. So therefore we will have two values, that is 40 plus square root of 448 divided by 6. This is one value of x, and another value of x is 40 minus 448 under the root divided by 6. Plugging these values into the calculator and finding the numerical value, we get x equals 10.19. This is rounded to two decimal places, or otherwise 3.14. Now we have to determine at which value of x the volume is maximum, and for that we can use the second derivative. So let me find the second derivative, p double prime of x, and this equals, so I'm going to use this expression, that is 12x squared minus 160x. This is the first derivative, p prime of x. This equals 12x squared minus 160x plus 384. So when we find its derivative, the derivative of 12x squared is 12 times the derivative of x squared is 2x, so it is 24x, minus the derivative of 160x is 160 times the derivative of x is 1, so it is negative 160, and then the derivative of 384 is 0. So this is the second derivative. Now we should plug in both values and find at which point the volume is maximum. That is, when the second derivative is negative, it is a point of maximum. So if we plug in 10.9 into this, we get 24 times 10.9 minus 160. This is going to be positive because 24 times, if we approximate this to 10, this is 240 minus 160 is going to be greater than 0. And if it is greater than 0, according to the second derivative, it's a point of minimum. So the volume is minimum when x equal to 10.19. So we can ignore this. We do not need this. Now let's plug in x equal to 3.14. And so when we do that, we get 24 times 3.14 minus 160. And so this will be 24 times 3 is little bit greater than 72, and 72 minus 160, this will be less than 0. And since the second derivative is negative here, it's a point of maximum. So therefore, we can consider this x. That is, only when x equal to 3.14, the volume is minimum. Otherwise, if we consider this x as 10.19 inches, this is not in the domain of the function, volume function, because we won't be able to cut 16 minus 2 times of 10.19, because this will become a negative. 16 minus 2 times 10 is 20. So we won't be able to cut when x equal to 10.19. So it is not in the domain of the volume function. So that is why we ignore that. And so therefore we can now see that only at x equals 3.14, the volume is maximum. Volume of the box is maximum. Therefore, we can find the dimensions. We write the dimensions of the box, which is 16 minus 2x, and so this gives 16 minus 2 times of 3.14. This equals 9.72 inches. And then we have 24 minus 2x. This is the width of the box, and so this gives 24 minus, replace x by 3.14, and so this gives 17.72 inches. And finally the height of the box, which is x, and so this equals 3.14 inches. So we have determined the dimensions of the box, that is 9.72, 17.72 inches, and then 3.1 inches. These dimensions gives the volume, maximum volume of the box.